Thanks for coming to the Cloud Robotics Working Group, and particular thanks to Benji, who is our special guest for today. He's our expert in, I would say, expert in logging and observability, but while Benji and I were talking, he said he has some notes on the word observability, which I'm sure we can discuss in this session. So in the last session, we discussed some possible topics and discussions to have. So I'm going to grab those and paste them into our group chat, but let that not delay the discussion, please. Anyone who wants to ask anything of Benji, please go ahead. We're looking to build a community guide on logging and observability. So yeah, this is an open discussion. Let's get some information.
And Michael, I have some slides, and I can do demos, of course, as well of what we've built. So let me know how you want to handle it.
Maybe we should start with that, and then that can lead into a discussion. That makes sense.
Sure, yeah. Otherwise, you probably have little context on who we are and what we do. Okay, so should I just share my screen? Should we get started?
Please, that sounds great. Yeah.
Okay, super cool. Okay, is that coming through for everyone? Okay, I'm seeing some thumbs and nods. That's always a good sign. Okay. Well, hi everyone. Thanks so much for having me here. I was honored to be invited. I think it's really cool. I have been following the Cloud Robotics working group kind of behind the scenes. I was at some of the first meetings, and then the reality of running a startup kind of, made me not able to join every subsequent meeting. But I read all the, discourse notes and things like that. So I'm fairly up to date, I think, with what you guys are talking about. We were just talking through, but my co-founder is actually in Zurich. I'm based in Seattle. Most of our team is here on the West Coast, though, in the US. We ended up starting the company. We were working at Amazon Robotics for several years on a range of different robotics projects at Amazon, actually, from drones through to like warehouse robotics, all the way through to even some projects in AWS. So we're really kind of Amazon roboticists, I guess, by training. And so if I have any biases, it's probably from my experiences there. And you'll hear kind of as I walk through some slides here, we started the company really due to frustrations that we had as robotics engineers working at Amazon on very large scale robotics projects. And of course, a big component of that was the data, which we'll get onto. We eventually left Amazon after several years. We wanted to start a company in the space. We had a pretty clear idea. We went through an accelerator called the Allen Institute for AI here in Seattle. They're a research organization. They actually did a lot of the early research on large language models. There was kind of a large language model that no one really knows called Elmo, unless you're sort of in the space. That eventually kind of became BERT and Roberta, and eventually led to all the sort of GPTs and subsequent revolutions. So they're a really interesting research organization that are quite low key. So I would pay attention to what they're doing. Yeah, and since then we've raised some venture capital, and I'll tell you about all the things that we've been building since. But maybe just as a sort of starting point, I figured given the context of this discussion, I'll give you like my sort of simplified view of robotics data, especially how we saw it play out at Amazon, and also how we see it generally play out at lots of different robotics companies that we now sort of get the ability to work with and sort of see inside of. So I think the best place to start is that from my perspective, robots produce two different types of data. And I think it's worth just covering both. And the second one is the one that I'll spend most of my time on, actually. So the first category of robotics data, in my opinion, is what I would call telemetry. And this is kind of the low frequency, low volume, you can think about it as over the air data that's getting kind of beamed back from, maybe every robot you have to some kind of maybe cloud storage or, local on-premise management system. And this is, of course, the kind of data that gets used for operational monitoring and fleet management. I often think about this kind of data as almost IoT style data, right? Like, where are all my robots right now? Which robots are having low battery levels? Have any robots got faults right now? Can I go and just see the video feed quickly from one of the robots potentially? I kind of mentally categorize that all as sort of telemetry data that's going over the air. And I think there's almost different companies, different products that are obviously worth digging into in this context. Maybe Christian, I think even of course what you're doing with Transitive, I would mentally have in this category. But let me know if that's not true. So that's kind of the first category. The second category I think of as robotics data as well is what I would call log files, and maybe colloquially in this community just get called bags. I always find bags kind of a fun term because it's just like a bag of stuff. It's got a lot of things in. And I think about this data as being much larger and much higher frequency. Of course, I guess everyone here has probably recorded a ROS bag in their life, but you end up with gigabytes, maybe terabytes of data per device per day, and they're usually like they're files that are being written to the robot, and in many cases people may not even bother taking them off the robot, or they may have some kind of rolling buffer on the robot because they just don't want to record everything, and they want to try and be careful about when they're recording and when they're not recording, because the volume of the data can get so large that you need to think about that in advance. But most companies we actually work with, we see still they just record everything on the robot, and then they'll make a decision about whether to eventually delete it or maybe pull it off for an instant investigation. And this data, unlike the telemetry data, gets used for pretty different things. It's a very key component of the R&D cycle, and it's a very important component for any crash analysis or incident investigation, because you're going to need that higher frequency data, because that's usually where a lot of the nasty stuff might have been. And of course, you need to understand the internal state of the vehicle or the robot, not necessarily just its external behaviors. And Michael, you were touching there on my sort of slight trepidation with the term observability. The reason I have some hesitation about that is because observability kind of implies you're observing, you're just looking at the external outputs of the system, as opposed to the internal state of the system, which is usually being captured in these kind of robot log files or bags, where you're capturing maybe every sensor output, every algorithm input and output, timing information across multiple compute nodes that might be on that robot. So it's a very different kind of data. And then if we just double click a bit more into these kind of bag files, of course, this shouldn't be surprising, I think, for this audience, but ROS bag files or log files, or whatever we want to call them, they're usually binaries of some variety, and they contain this multimodality of data, right? There might be images, there might be point cloud topics, lots of tabular time series topics, motor speeds, actuator commands. There's often even text like console logs, and all the kind of algorithm IO and more, like we were just talking about as well. So this is kind of the crux of all the data that I'm going to be talking about today, is kind of this kind of data. I'm not really talking about telemetry data that I was sort of discussing in the first category before. Okay, so the problem that we had at Amazon, which is what motivated us to start this company, was this. The problem with these kind of robot log files and bag files, as I alluded to before, is that you end up in a situation where you just end up with tons of them very quickly. And most people never fully anticipate how quickly you end up generating these bag files or log files. They end up littering your computer, littering your desktop. They, take ages to transfer and move around. It's difficult to work with them. But as I said, any of these log or bag files might contain really important errors or edge cases. And so, you should have some motivation to know what the hell's going on in them. And then what we saw at Amazon as we started scaling up different robotics programs, you go from this situation, which already is pretty crappy, to this situation, which is really bad, where, you start, maybe you're lucky enough to cross the double chasm of robotics and get to having a fleet of robots. And then you start drowning in all of that, log and sensor and bag data that's collected. And what usually happens, the usual remedy for this stuff is companies will just try and start logging less. And you have to be pretty careful, of course, about where you're deciding to log less stuff, because that might end up, biting you in the ass potentially. I think really the only companies at this point that have gotten to the maturity level where they can very intelligently log much less data are probably the companies like Waymo, to some extent Amazon Robotics, maybe Tesla. We're not really sure how far along their projects are, but they have a very good understanding of when something interesting is happening on a robot, and can probably be more careful or particular about when they're choosing to record that data. But for all intents and purposes, most companies still record pretty much the full shebang. And so what we noticed at Amazon was that really that first point, engineers and operators just struggle to analyze all of this data. It's just not a very scalable process. And the second thing here was the most pertinent issue we found, that really most of these logs get ignored or even deleted unless something very bad happens. So of course, if there's a crash, someone's going to have to go and pull the logs off and figure out what the hell happened, especially if it was a safety critical system or something that could hurt people. There's usually a lot of motivation to do a serious investigation into that. But for most of the data, where you think everything's totally fine, most of the logs never really get looked into, right? Like, oh yeah, that drive was fine, or that flight was fine, or that, that pick and place task was totally fine. We don't need to look at the logs. But what we discovered at Amazon was that every time we had pretty serious crashes and pretty serious incidents, if we had actually been looking at a lot of, that more nominal data, we actually might have discovered that there was some ticking time bombs kind of under the hood that were lurking and waiting to strike. So this was sort of the big learning we had in it, and it would affect, deployments downstream. We always sort of were upset when we discovered an issue that we could have found several months earlier if we'd paid more attention to some of that, data where everything seemed fine. Hopefully I shouldn't need to go through this too much, but it's a hard problem, right? Like analyzing robotics logs at scale is difficult. From our perspective, it needs a very specialist data platform. I've got the innards of a ROS bag here, and I kind of zoom in. This is a 20 gigabyte file that's only 15 minutes long, something like that, and it's got thousands and thousands of messages across many different types of topics, across many different types of sensors, and so just making sense of all that is challenging. From our perspective, status quo platforms just don't really have a hope in hell to process and analyze this stuff. We do meet robotics companies that are trying to throw all of their high frequency time series data into time series databases and other sort of data management solutions. They end up just with very, very large bills and with products that don't work very well because they have had to split up all the modalities essentially. So it's a easy mistake to make, we find, just trying to throw everything into time series databases. So we had this kind of idea before, we started the company, and then we kind of formalized it, but we just wondered if there was a way really to kind of more automatically index and review all of this kind of log data, whether there was ways to just make searching for these kind of edge cases and nasty behaviors faster and more intuitive. And of course, this seemed like a pipe dream a couple of years ago, but it's become more and more, plausible. But whether we could use AI to also help surface important issues that otherwise we wouldn't have been paying attention to if we hadn't noticed anything in those logs. And then the dream is that will enable the robotics industry writ large to kind of scale up deployments more successfully, because I think that's been kind of the bane of most robotics companies over the last decade or so. And that's why we built Roboto. So Roboto, from our perspective, is really a robotics data analysis platform. What does that mean? From our perspective, that means we kind of offer these 4 key kind of pieces of a stack. And really at the lowest level here, you can think of, we start working with robotics companies. They maybe have an S3 bucket full of, bag files, and they can click that S3 bucket into Roboto. And then we make it easy to organize all of that data into various data sets. A data set could be, one robot's activity for a given day. It might be a single flight of a drone. We kind of have some flexible kind of data model that companies map their sort of operations and ontology to. But once the data is sort of being managed by Roboto, we expose a very powerful post-processing engine. And really, I would kind of, if I was hearing those words for the first time, I'd be a bit like, what the hell is that? You can think about this processing engine as a bit like GitHub Actions, but for robotic data. So every time new logs come into the system, you can configure rules that help you decide how you want to post-process that data and maybe what you want to do with it. So it could be like every time Michael uploads these robots from his drone, it's going to automatically post-process them and generate various reports that he wants. And you can actually orchestrate your own custom code inside Roboto. So these actions can be user-defined in a way. So it might be, every time I upload a log file, I want to scan it for certain things. And if that error message is in that log, I want to tag that log. So you can set up these data pipelines essentially. And then we have a very powerful search layer as well. So once all the robot log data has been kind of indexed by Roboto, you can do queries across the log data, and I'll show you kind of what that means. We have a few different types of ways that we do queries. Some are more kind of structured, queries where I just want to find all the logs where, some signal went above some threshold. And we can also do some more interesting kind of searches where you can actually find patterns in the time series data potentially. So maybe you want to find all the times your motor has exhibited some weird signature in the motor behavior. And then finally, we have even analytics tools that help you, aggregate all of that robotic log data you've got, because maybe you want to start asking questions like, how's our CPU performance changed, over the last, 3 months, given that we've changed, firmware or software version several times? What's the behavior looking like of the system? Kind of, are we seeing any, concerning trends? So yeah, that's the general stack that we've put together at Roboto, and this is sort of just another way of looking at that. We ultimately help companies organize their raw log files into data sets. We have very first-class support for, ROS1 bags, ROS2 MCAP files, PX4 drone, ulog files. But kind of crucially, actually, we're also agnostic. So if companies, which happens pretty often, like I'm still sad to say it happens pretty often that companies roll their own binary formats for their own logs, and we have a way to kind of click those in as well. So it's usually not a big stretch for us to add in essentially a company's custom log file. And that flexibility has given us a lot of options with companies when we work with them, which is great. And then I just talked about post-processing. So, data comes in, we're able to post-process it with this kind of action system that we have. We have a lot of off-the-shelf actions, which I'll show you, but we also allow companies and users to just create their own custom actions, which are really just Dockerized scripts and code that they want to run on their data every time it comes in. And then finally, the cool stuff, we're able to find kind of interesting patterns and events in the data. And I'll show you a couple of demos of these kinds of things. But maybe I'll just pause there for a minute before I get into some demos. And feel free to harass me and tell me if you have violent disagreements with any terms I used.
I just realized I was still muted in the recording. Yeah, I said I wouldn't call it violent, but I do wonder about observability. I feel like it might be the right term because it's essentially how well you can observe something. So if you have a high degree of observability, doesn't that mean you can observe more, including the internal state? I'm not married to the term. I'm just, I remember that. And I had a couple of questions from watching it. That was such a nitpick, by the way. I'm not even expecting a response. Don't worry. So one of the questions was, I wrote it very long, and now I'm trying to summarize it on the call. So when you upload from the robot, it sounds like what you tend to do is you expect the log files to be written to disk and then uploaded after the fact. Do you have any that upload live, and what kind of bandwidth, what kind of behaviors do you see from people trying to do that?
Yeah, so I mean, I would never call it live in our context. Usually it might be like soft real time for some companies where, a drone might be flying, it finishes its flight, and then it uploads the data to Roboto, for example. So it's certainly not during the flight though. And in some cases where companies have more like a continuous robot operation of some form, they might choose to be, every 5 minutes, they kind of write some kind of log file and then upload it. So we definitely don't handle any kind of like hard real-time observability, let's say in this context, or monitoring. From my perspective, that is the remit of the kind of, when I was just going through those slides earlier, that for me is typically the remit of like telemetry data. Because if you want that level of real-time sort of, interaction with that fleet of robots, it's going to need to be kind of a pretty different shape of data. That's usually what I found, at least. But I think the reason I put in the slides that this was a simplified view of robotics data was that for some companies there's a pretty blurry middle ground between these two things. Actually, they might be kind of semi-abusing a telemetry link to send a lot more, back to a real-time monitoring system versus writing kind of heavy logs on device. Some companies have very, very discrete separation of concerns for these kinds of systems. At Amazon, especially on the drone project, we had a very different stack that was producing this kind of lower frequency telemetry data that was going to our fleet management systems versus the kind of raw sensor data or algorithm data that was being logged to the vehicles. And that, even from a certification perspective, was important that was a separation of concerns.
That does make sense. I think you mentioned, can I see a live video view from the robot? Video would be one of the gray areas, right?
Exactly. And I think it makes sense. You often need that for situational awareness, but there's still a big difference between sending, a 10 hertz video stream back versus a, image every second or something like that. So there's still usually a difference in the telemetry frequency.
And then my other question, now that I read it, I think it's going to be answered by your demo next anyway, so I'm going to hold that one back in case it's not answered. So thank you.
I wanted to use the opportunity to follow up on that upload, because I also had a question around that. Do you have an agent on your customers' devices, or does your work start with the S3 bucket?
It's really the latter, but we also have an agent for companies that just wanted a bit of extra help to like even get their data to their own S3 bucket in the first place. So we have kind of a lightweight agent, I would call it, and it's really more of a utility for earlier stage companies that we work with that just didn't have the cycles to necessarily figure that part out themselves. So we could kind of bootstrap them into the downstream analysis faster.
The reason I'm asking is because in this group, when we previously talked about it, we discussed the point that comes up fairly regularly with robotics companies, which is this sort of event-triggered uploads. Is this something that you see with your customers? Do they ask about that? Like, I mean, you mentioned a crash, right? Usually that's detected by a human, but it could also be detected by a robot. Have you explored that at all?
Yeah, definitely. I think, in my opinion, I have very strong opinions about that because it's a slippery slope. I think it's one of those things that a company should really be careful about if they start being, selective about when they're recording data. At the end of the day, data storage is pretty cheap. So there's usually not a particularly good reason, unless you're like Waymo size, to like not record everything and just capture everything and keep it. The thing that's expensive sometimes and complicated is transfer, right? Like often even in some Amazon robotics projects, it was faster for us to ship data, literally physically ship it to S3 versus, sit on an Ethernet link and then bother uploading it. So that can be annoying. I think that's sometimes a good reason to reduce the volume, or sometimes just reduce the frequency of the data being collected. But what makes me worried sometimes about this more event-oriented capturing, unless you have a very, very good way of discovering those interesting events, you might well end up not recording data during, moments where the robot was actually experiencing an edge case that you just weren't familiar with, and now you ultimately didn't bother recording, any data during that time frame. So that makes me nervous.
I love this conversation, but I want to challenge it. And the way I want to challenge it particularly is that you say you should basically record everything. I would argue that nobody's actually recording everything, because in robotics, as you know, especially if you have a 3D LiDAR, right? Point clouds really don't compress well, and if you record it at the full resolution, your disk will be full in 2 minutes. Kid you not, right? That's roughly the time scale. So I think the question of when to record what is unavoidable. And then the question, and that's where I'm really interested in that question, because at Sevilla we went in circles on that. We sometimes said, well, we should always record everything, and then but sort of at a low frequency or high fidelity, and then sort of you suggested that too, right? Like increase resolution or frequency or something like that under certain circumstances. But then the magic comes down to the difficult problem you just acknowledged, which is knowing for sure that you are capturing all of that.
Yeah. Actually, you asked originally, have we explored that stuff? And I'll show you kind of one of the technologies we've been investing in, but something that we've been trying to build as well is, you have maybe a lot of data sitting in your S3 bucket. Is there a way to capture from all that data kind of a good understanding of all the things you've seen before, so that you would then have something that you could potentially deploy on robot that could be a more intelligent sieve of, we've seen this before. We are in a pretty nominal situation right now. We don't need to record what's happening right now at high frequency. And then you can crank that up as you enter a situation which is potentially off nominal versus all the data you've seen before. So I think that kind of almost intelligent edge filtering is the name of the game.
Anomaly detection, right? Like a lot of people have been, I think even in Orbit originally, I think pitched when they were fundraising, they were pitching it on automated anomaly detection, which just happens to be really hard. I haven't seen any good solutions yet, but yeah, I think it sort of comes from that. Thank you.
It's leaky cauldrons as well, where I think it makes sense to be investing at that stuff when you're at a decent scale, but I think a lot of companies maybe almost entertain doing that too early, because there's so much else that they need to figure out. Like, there's no way they've even got enough performance data to understand what, you know, is anomalous at that point, right? So
I agree. I was attending a talk by Waymo several years ago, and she was, I think it was Alison. You probably know her. I forget her last name, but she was describing this problem that they have so much data, but most of it is uninteresting, and so they were particularly interested in she called it identifying adversarial conditions. So it's So I mean, which is another way of saying things that the car struggled with, or could have struggled with.
I like that.
I agree. That's sort of, once you want to go from the 99 to the 99.9, most companies are still struggling to go from 90 to 95 or to 99, and that's where there's much more low-hanging fruit.
I like that adversarial term, because it reminds me in that kind of autonomous vehicle space where, do you remember there was that period where the road signs, people were like able to spray them and create an adversarial road sign? So it's probably derived also from that, because I think they had a lot of issues with that.
Exactly.
Is the stop sign I'm looking at a real stop sign, or is it am I just being told it's a stop sign? Scary. Cool. Any other quick questions? Otherwise, I'll just show some. I can show some quick demos, then we can get back to discussing. Yeah. Okay. Cool. Well, let me change window. So I'll just give you guys I'll give you a very quick tour of Roboto. This will be like, you know, I'll just show a fraction of the stuff that I might typically show a robotics company if I was meeting them, because I think that's probably the right framing for this kind of audience. And I'll probably focus more on the stuff that we do that helps with some of the problems that I was describing. So I'm logged into Roboto here. I'm just in a dummy organization. This organization is quite nice because I just have a lot of PX4 ulog data in here. But assume everything I'm showing is just completely functionally equivalent with ROS bags, with MCAP files. It's all handled essentially the same way by the system. I can pull those up if we really want to see those too. But there's some nice examples here. So if I click into kind of our primitive here, which is called a data set, you can always just come into Roboto and create a new data set. And really, once you've made a data set, you can think about it a bit like a Dropbox folder for various robotics data formats, and also any auxiliary files that you might have. As I mentioned, a lot of companies actually they want to have their data in their own S3 bucket, and they'll connect their S3 bucket to Roboto. And then there's a way of kind of importing data from a S3 bucket into Roboto without needing to kind of copy and duplicate it. We can just kind of source it directly from the S3 bucket. But in this case, I just dragged in a couple of these files. The first thing to notice is I've got like 2 ULG files here. This is just the file format that's produced by the PX4 autopilot. It's like a ROS bag. And you'll notice that it says that I uploaded these. They came from Benji at Roboto.AI. But these 2 HTML files here, they were actually produced by an action invocation that ran in our system. So basically, I uploaded this ULG file, and that automatically kicked off an action that ran, which then did something called PX4 flight review, and it mounted in those log files, and actually then ultimately produced the HTML file that also then got dropped into this data set. So you can already see like that was just a very, very short kind of data pipeline that I'd created, where I can add raw log files in and then run my own custom post-processing to produce these additional HTML files that got produced. But I'm not going to focus too much on those right now. What I'm going to focus on is, because this ULG file format, like MCAP, like .bag for ROS, we treat in a first-class way. When these file formats come in, we also index and almost statistically summarize all the data that's in these log files. And so if I click into this log file, you can actually see we pull in all the metadata that's written in kind of the headers of these ULG files. And that might be like what firmware version, what hardware version, various other kind of UUIDs that get captured. But more interestingly, there's all the like time series data that is captured into essentially topics, much like a ROS bag or an MCAP file. And for any of these individual topics, maybe I can zoom in a little bit in case it's small for you guys. In any of these individual topics, I can actually click into them and see the fields within that topic, and even the statistics around those fields. So I see like CPU load was 37% minimum and 80% almost maximum. And I'll show you a little bit later how we kind of end up leveraging these statistics that get generated. But if I just zoom out again for a second, we ingest and index these files. Once they're ingested and indexed, you can double click onto them as well. And then you get taken into kind of an RViz style visualization experience. And it's worth showing too, you can always pull in even multiple files as well. So I could be like, I want to pull in this ULG file and this ULG file, because maybe I want to compare the CPU load in one of the files to the CPU load in another one of the files. So I can even do like a, run-to-run analysis of maybe even different vehicles or different back-to-back runs that I've done. So actually we can do literally what I just said as well. I could pull up the CPU load from this one flight that we had. I'm just going to turn off the events for a second, just so it doesn't get too noisy for us visually. And I could pull up the CPU load of the second flight as well. And did I just do the same one twice? Probably. Let's go up here. CPU load. There we go. Should look different. Yeah. So we can see like, oh, now in this flight, we were only at 30% CPU load, and in this flight we were actually close to 50%. So you can do a bit of like comparative analysis there. But what I wanted to show was if I come into a different data set here, let's see, maybe these ones. These are kind of nice to look at. I can also pull up, various RViz style like time series signals. You can also pull up map data, things like that. What I wanted to show though was if I just pull up CPU load again in this flight, you can see actually I have all the different events highlighted here as well. I didn't manually go in and create these ranges of time. These were automatically extracted for me, also with an action. So every time I upload a ULG file here, it actually analyzes the state machine and then will automatically create events for me for each of those different state transitions that in this case drone went through. So we can see that we were in some stabilized mode, then we were in a mission mode, then we were in return to land, ultimately back into stabilized, et cetera, et cetera. And all of these events get pulled out and generated, and companies we work with actually produce their own events, given their own state machines, and they'll do their own custom analysis here. And we quickly ran into this interesting problem of like, okay, well, you have tons of events that you can be pulling out of these log files as you post-process them. How can you get a kind of more, at a glance summary of like whether anything interesting happened? Kind of to the point I made during the presentation, like how do I know whether something interesting happened in this run? And we have this kind of cool little AI feature now that we've been building, where it'll actually give me a summary of the key things that happened by traversing all of that log and event data that was created. So in this case, I can see like it's telling me there was a fail-safe activation in this flight. And if I actually click it, it'll take me to the specific log line where that happened. And maybe because this is some drone data, we probably should have some map data, so we can actually see like when on the map this actually happened, or like where in the flight this problem occurred potentially. So we can see it kind of happened. This like fail-safe activation happened at kind of this point in the flight. If I wanted to, I could hit play and actually see the log file play back for me. But you guys have all seen that before, so I don't need to show that kind of stuff. Other interesting things. Let's see what else it has to tell me. There was some high vibration levels apparently, so I can pull that up. That's actually opening up a vibration metric graph that is a sort of derivative topic that was being created here. So for whatever reason, it thinks that this was a kind of high vibration level that needed some attention. That might be configurable as well. So yeah, you can kind of just get these at a glance summaries. Companies are finding these very helpful just to kind of, they thought everything was fine in a flight, and then they actually pull it up and they're like, oh damn, there was some pretty scary warnings and errors and alerts here that we would have had no idea about otherwise, because it went and did its thing and came back and everything seemed okay. So that's kind of just the visualization side of the event here. You can always, maybe it's just worth showing, if something interesting happens as well while you're actually analyzing the data, you can always come in here and even like do your own event annotation. So if I turn these off, I can actually come in here and be like, something interesting happened in this time frame. Maybe this is when we had some nasty crash, for example. So I can annotate that as well myself, and it'll stay there, and then that'll actually feed into the AI beast. If I kind of regenerate this now, it even has some extra context that I can be capturing as a kind of expert reviewer of this data, so it kind of further enriches it over time. So yeah, that's kind of just being able to compare, look at stuff, use log files. I promised I'd show how we use that search and statistics capability. So I'll show you very quickly kind of what that looks like. I can come in here and start doing queries across all my data. I can do things like, I want to find log files where the CPU load, which stick with that example, you see I get all this nice autocomplete, where the CPU load went above 80%. Let's see if like any log files we've uploaded match that criteria. And in this case, yeah, we see we've got 100 results or so. I can even further drill down. I could be like, well, this is like all the logs I've uploaded, but I'm only interested in the ones where the hardware version was this tag basically. And so I can then further say, and there's a bit of metadata on the file called the hardware version, and I want that to be px4 FMUv3. And now we've gone from 100 log files to 17. And from these search results, I can then go from I can go from an individual result even back into the CPU load data for that flight and open it directly. So I can go from like search straight back into the data visualization here and see, yeah, oh, this was a flight where we almost got to 90% on our CPU. That might be kind of scary for whatever reason. That's kind of search in this context. And then I'll show you another kind of search that we've been working on recently, which is really cool, really excited about it. So I'll just show you, actually maybe what I'll do is share my screen on a different window for a second. Just give me 1 sec, because I can actually show you the real thing running. If I come here, window. Okay, this new window should be open. So I'm actually just using some of the robot data here because we had the hackathon at our office this weekend, so we have a lot of the robot data. In this case, this is a data set that contains tons of different episodes of robotics data that might be used in some kind of training process. You can see here we also support like Parquet and MP4 files. I'm just going to open these up in the visualizer that we have. I'm just going to turn off one of these events, and then I'm going to pull up a layout, which just opens up this manipulation data in this case. And you can see here, this is a really simple episode, but essentially it's a robot that's coming along and it's opening a cupboard with 2 arms. And then when we get to this highlighted region that I've highlighted down here, the robot kind of like grasps the pot and puts it in a cupboard, essentially. So you'll see that it's kind of moving it up and putting it in a cupboard. So I've highlighted this region where, if I just go back to the beginning of that region then, where it kind of starts picking up the pot, puts it in the cupboard. So we asked this question, like, we might have thousands and thousands of episodes or logs or whatever we might have. How could I now find all the times we've made this movement before, where we've like picked something up and put it in a cupboard, for example, across many other different episodes that we have? And so what we're able to do, once you've kind of annotated an event like this, you can actually then bring it into our SDK, and then you can do a signal similarity search on all this data. So I'll show you what that looks like. I'm just going to go back to my original window because I have it in another tab. But this is cool stuff. So here we go. This is coming through now. So hopefully you should see a notebook environment. So here, I've taken the event ID that we created before, and what I'm able to do now is I can run a SDK command we have called find similar signals, and really what that lets me do is take this multidimensional signal that corresponded to that one lifting event and putting it in a cupboard, and I can find all the other times we've seen a multidimensional event that looks like that one. But you can see that actually in these cases, we were lifting completely different objects, but we were making kind of the same motion. And this is a really cool primitive that seems to work really well across lots of different types of robotics data. We've been trying it with some manipulation data recently, just because we were taking part in this the robot hackathon. So here's another example. We found all the times where these 2 robot arms were kind of folding a piece of clothing forward, and then you can go and find all the other times essentially where it did that. We've also done it with drone data as well. So we kind of can take the IMU data from a drone and find all the times where a drone has had a hard landing, or all the times the drone was being calibrated or made a fast turn. So it's a really powerful primitive, and the reason we're able to do this efficiently is by virtue of how we slice up an index and make the data accessible in a kind of columnar form, so that you can run this kind of analytics across all the data very efficiently. So this is just one example.
That's really cool. But let me understand that a little bit better. So you're marking that episode. That much I understand.
Mm-hmm.
How does the classifier? I mean, this is a classification kind of problem, right? You're trying to find time segments that are similar to this one, or are you just? Is it based on the curves that we see? Is it some sort of distance measure between those curves, like a basic sort of KNN nearest neighbor type of classifier that exploits your index, or how should I think about it?
Yeah, honestly, we've tried lots of different ways to do it. We've kind of settled on a bit of a hybrid approach. The thing we found that worked most effectively in this case was actually even some time series similarity algorithms that were inspired by like literature and seismology and finance, because
Wow.
they have an interest in finding patterns in data. But
There's money in that. Yeah.
there's money in that. Maybe not in robotics, but we'll find out. But it's sort of that kind of time series analysis is really interesting. There's
But you're doing it across multiple time series, right? Like, because you're showing multiple graphs here, it wouldn't be a fit if only, let's say, the red curve matches, but you simultaneously want. Okay.
Yeah, that's exactly right. I'll show you some other examples because we have a blog post actually about it from recently for some drone data too. You'll like this one. So here I was just annotating kind of. This is a pretty simple example, but I was annotating kind of a hard landing that a drone had where it kind of crashed into the ground. And then we can find all the other times, where we saw kind of a spike in the IMU data, and it does correspond to kind of these like, hard landings. That was kind of the first thing we tried. But then we made it more interesting. We wanted to find all the times the stereo cameras on the drone were calibrated, but we didn't look at any of the images. So we just looked at, again, the IMU data to see if there was a signature in the IMU data that corresponded to, say, camera calibration. And it did, because the drone gets picked up, it typically gets moved in kind of a figure of 8 pattern, and then it gets put back down on the ground. And that essentially is exhibited by this kind of pattern in the robotic IMU data. So we just found it's a very efficient way to retrieve instances of things that are interesting. And then to our conversation earlier, Christian, like, we think this is a great primitive to then ask questions like, I've had a problem. Is it the first time I'm seeing this, or have I seen this a lot of times, across all the logs I've got? And kind of the inverse is interesting too. Like, have we ever seen this before? No. Maybe it's anomalous. Maybe it's interesting. Maybe it's something that is worth capturing right now because we haven't seen something like this. So we think there's kind of a really interesting dotted line between kind of this primitive and some of the things that we were just talking about earlier. So maybe I'll pause there. I don't want to take up too much time with loads of demos. There's lots of other stuff I could demo and show you guys. Maybe just one thing, just for the sake of conversation, that's helpful to show quickly. Once data is ingested into the system, we also have kind of a really nice abstraction layer where if you want to write a custom action to post-process the data afterwards, you only need to work in really data frames, ultimately, especially if it's just the time series numerical data. So if you've uploaded a ROSBAG, all the topics get kind of like normalized in a way, and then accessible through a data frame kind of process. So here, this is the entire code for an action that I ran in Roboto to just analyze the magnetometer data and determine if the norm of the magnetometer data implied there might be some signal interference or GPS interference. And this is the entire code. I'm able to basically say like, hey, ROSBAG file, I want just this sensor magnetometer topic. Now just get me that data as a data frame, and then I can do some custom analysis with that. So we've really focused on just trying to make it very simple for like downstream analytics scripts and use cases to, just access the slice of the data they want and not have to bother about unpacking a complex log binary file format. So anyway, I thought I'd just share that quickly because it's kind of useful context. Anyway, I'll pause there. Hopefully we can, I didn't want to spend too much time demoing stuff.
I had a quick question. Can you do I imagine you can because it's custom actions, right? But can you do alarms when you do actions?
Yes, exactly. So that's kind of I actually don't think we have that in our hub, but just for the sake of showing here, we have kind of an action hub, and that has a bunch of kind of off-the-shelf actions in here. Some are actually like, some companies will run, a full algorithm as an action for like regression analysis. Like every time I upload a log file, actually run this new version of the SLAM algorithm that I'm thinking of moving my robot onto. Some companies, exactly as you said, Michael, will post-process the data and then fire a Slack alert or fire some kind of alarm if something interesting happens. Like, oh, we detected that pattern again in our motors. We need to send an alert to the maintenance team because maybe this robot needs to be pulled off now because the motors are having that issue that usually means they're going to brown out soon. So yeah, that's a pretty common workflow we see.
Well, the reason I thought of it is that as a developer, you can update some code and then also write a custom action to alert you if the issue ever happens again. It sort of feeds into an automated testing suite.
Yeah,
that sounds very cool.
Yeah, one company actually that we just published a case study with, they we didn't even know this was a use case they were interested in. They just started doing it, but they produced their kind of vehicles in the manufacturing process, and now at the end of their manufacturing process, they send the logs to Roboto for analysis, and also they run their own custom analysis, like you were talking about, and Roboto will then kind of give them a sort of like yes or no whether that is now ready to be shipped to a customer, like from a manufacturing process. So we never really considered end of line testing like that, but you actually you just preempted that, which was cool. We never really thought of that use case.
Well, that's very similar to, I mean, earlier you compared it to GitHub Actions, but that's sort of where, you know, CI/CD, yeah, it's like CI/CD for robotics, like QA. But I mean, CI/CD basically, you know, all of the tests are basically like an automated QA function, and that's sort of what you're seeming to serve with your manufacturing partner there. That's pretty cool.
Yeah, that sounds. Giovanni, you have a hand up.
Yes, sir. Wonderful demo, Benji. Really cool. Just for my understanding, I wanted to delve a bit deeper in the demo you showed about the similarity. You just annotated the times. So you just said, this is the series of time I'm interested in. You didn't even choose the features, right? So what are the lines that we're seeing there? Are the joint positions, or what are those are joint? Did you have to choose the features, or you are able to just say, this is the time sequence I'm interested in, just find something similar all over the place?
That's a good question. Yeah, you generally do choose the features or the signals in this case. What I had showed in that example, actually I can pull up, let's say, without changing my screen around again, but here's the example here. Like in this case, I was annotating a region of IMU data, and you can see this IMU data is just the linear acceleration X, Y, and Z. So by creating this event around that data, I'm sort of associating it with the concept of linear acceleration X, Y, and Z. So for us, an event is a time range and some number of signals that relate.
So you chose the features. That was the thing I didn't understand. Yeah, thank you.
But worth saying though, what we find actually is that we still experiment. So you can see here I go and get the data from the event here's the event that I created, and then I go and get the data from the event. And here I'm actually taking I think this is like 10, probably 10 motor signals. They might be kind of joint angles. I'd have to double check, but we can think about them as sort of motor signals. If I wanted to though, I could now rerun the similarity search, and maybe I only want to look at the left robot arm data, for example. I can decide what to exclude or include in the actual similarity search though that I'm running. So you can be kind of selective, and we actually find that's kind of interesting. Like when we were looking at the drone data, when we were looking at like trying to detect fast left turns in the drone data, we saw like we obviously want to provide the angular velocity data, but does the linear acceleration data make any difference, or does it just make the search slower because we're now searching more signals? So you obviously want to like use as little data as possible to compare, but still try and find the motivation behind the signal in a way.
No, but it's fantastic that it's so easy to change the features that you're selecting, and you still are able to scale the query across all the data that you have. That's really impressive.
Exactly. And it's probably worth saying, like, this is just one example of this is kind of an algorithm that we just provide off the shelf, but some companies will write their own kind of thing like this, but they really just use Roboto because it enables them to go and kind of fetch the slices of data efficiently and run that across,
Yeah, but now to connect to what the adversarial conditions or anomaly detection that Christian was talking about, I mean, this, in theory, you could also use it to do that, right? Because you would do that what you're saying before. You're recording 1 minute, 30 seconds constantly on the robot, and then now your little agent that runs on the robot knows the pattern it has to look for. So then it says, okay, if I'm matching this pattern, keep the data and actually send it to the cloud.
100%.
And then you could do this.
Can you actually do that? Because I thought this was running all in the cloud, and it requires you to have already indexed your time series in some sort of intelligent way.
Yeah, I mean, ultimately the algorithm would be the same, but you're right, the inputs would need a bit of massaging on an actual like robot. If we were running this on the robot, the input would be slightly different. It would need to be running in some, process where it can be listening, almost, let's say, as a ROS node that's like subscribing to the topic data, as opposed to reading it from a raw bag file or something like that.
Almost in real time, but it's easier because you're processing a single robot at a time. So
yeah, I think that would actually be pretty doable. We've not tried running this on the robot yet, but I think it would definitely be super interesting.
Well, now that I'm seeing this, I'm thinking, like, in my mind recently, I've been distinguishing between, I'll call it old robotics and new robotics. Although the old robotics should really be called the old new robotics, because the really old robotics is AGV, line following, and then the old new robotics is AMRs that don't need that anymore. But the new robotics.
You're showing your age there, Christian. You're showing your age.
I know, I totally do. Well, there's also the old that was before ROS, but. Let's get back to the new robotics right now, at least new in 2025, is this end-to-end learning, right? Which is kind of what you're showing here, and of course the Lee Robot Hackathon was all about that. This is sort of a new generation of robotics companies that sort of, in my mind, dismiss a little bit too easily the existing literature and tools out there for robotics. But that's how they think, right? They seem to be thinking they're inventing the future. They don't need state representations. They don't need ROS because everything is done end to end. This seems to really fit that, right? I mean, this example in particular, because of course they're drowning in data. Data is the name of the game, and I mean, this concept of active learning, right? Like what they need to do is they need to basically figure out, where is my model not yet good enough, and then design their data collection going forward accordingly. And for that, tools like this seem tremendously valuable. I don't know, have you spoken much? This was from a hackathon, but have you spoken much with these new end-to-end learning robotics companies? Is this something that you've explored with them, and how did they? I'd love to hear about them specifically, because because of their they're in the new robotics, they may be thinking about this whole process slightly differently.
Yeah, I mean, everything you said, I agree with, and I think it's totally correct. They definitely think about it differently. What I've noticed is that it's a very small subset of the robotics industry, though, that sort of exists that's thinking like this right now, and there's a lot of reasons for that, obviously, but it's really, of course, the humanoid robotics companies and some of the more bleeding edge, like robot arm companies, that are really trying to leverage this kind of end-to-end learning, as you said. I think most other robotics companies we meet, especially if they're in like a reliability or safety critical context, are not touching this stuff yet. They're not going to touch it, maybe even forever, because it's not going to be certifiable, or it's going to be much harder to prove. A big black box is safe versus a kind of well-defined, control system, navigation system, etc. So I think there's a lot of thought around that. I don't think, having immersed myself in the robot community more this weekend, I think it's trying to get people that are like excited about AI and software into robotics. And so it's not kind of like production grade stuff by any means that's being worked on there yet. It's really more on the, I said to someone recently, I think about it a bit like Arduino. It's like how if I was a hardcore electrical engineer, I'd think about Arduino. It's like really almost democratizing access to a cheap robot system that you can actually do some pretty amazing stuff with not much effort. But if you're going to scale that up into a real robotic system, especially in a more complex environment, it's going to have issues. But we did this specifically because, by virtue of the end-to-end learning that they're doing, they want to do a lot of episodic curation. So curation that becomes very important. They generate a lot of episodes. And then once the policy's been deployed and it's actually doing stuff in the real world, because they then don't really have a formalized state machine, they don't know what the robot's actually doing at any point in time in the traditional sense, right? They don't know we're in pickup mode, because that was some learned behavior.
There are no modes. There's
no modes. So in this context, we thought this was cool because, maybe they do want to find all the times they try to pick something up, or all the times they move the arm like this, or all the times they use some end effector to do something interesting. You actually need a tool to retrieve those cases so that you can then even decide if they were good or bad. I'll show you another just very quick example that I literally just put this blog post together yesterday, but this is just going through some of the stuff I've just shown you guys. But here's another example of some data where these bimanual arms are trying to take the lid off a little sauce container, and you'll see sometimes they work and sometimes they don't work. like, I don't remember if this one, yeah, that one didn't work. It like kind of, not enough force was applied for whatever reason. But now, they would at least be able to retrieve all these things and say, yes, success, failure, failure, success, success, and then potentially, tie that back into some, some system again to kind of retrain or fine tune or whatever they might need to do. So
fascinating. The other thing you could do, I don't know whether you've thought about that, is just some unsupervised learning. Right here, this is a classifier, but you could also potentially, you mentioned the problem with end-to-end not having modes. Well, it does have modes. They're just latent, right? Like you have to discover them. This seems like it could give you some handle on that, right? Where you could do some clustering or whatever you want to call it to group it into different categories, and then within each category you could still distinguish between success and failure.
100%.
Yeah, lots of possibilities. This is really cool.
We've been thinking of even combining this with even kind of then a VLM that is watching backwards too, right?
That's what I'm getting at. Yeah, I mean, I'm thinking of like the physical intelligence, these types of companies that work on VLMs or VLAs, right? Like visual language action models. Very cool.
Yeah, I think there's a lot. I mean, I think a lot of that stuff right now is almost happening on robot, but we're almost trying to push the boat and think like, how could these same technologies be used off the robot for that kind of data flywheel portion? And I think that's the thing that we think is becoming the holy grail in these robotics companies we meet, whether they're doing this end-to-end learning stuff or they're actually still, more in the like, old new category or new old category. I can't remember what you said. The data is still super important, like whether it's for instant investigation or education analysis, and that data maturity and the data flywheel becomes kind of the most important thing these companies need to figure out as they go from a few robots to a lot of robots, actually.
I'm realizing we're going to be kicked out in a
Yeah, I was just about to say. So the call does end for us, so I do need to cut in. Thanks so much for joining us, Benji. I think I've still got a lot of questions that weren't related to the presentation. I don't know if we should invite you back or I just send you the questions afterwards. So we'll discuss offline and see what to do for next session. But again, thank you for everyone for coming. The recording will be on YouTube, and I will see you next time in 2 weeks.
Thank you.
Thanks so much for having me.
Thanks, Benji. Good to see you.
Bye.
See you.